capacitor now. So let's try going place, components. Now we're still in basic. You can see that. I go to basic, and you can see down here I've got an option of a capacitor, and it defaults to 1 microfarad. That's not an unreasonable size capacitor. That's what I was showing you earlier over there. Click OK, plonk, and there's my 1 microfarad capacitor on screen, ready to be edited and used circuit from. Yeah, so good, but I don't want that now, so I'm just going to click on the one. I'm going to click on the 1 microfarad, and I'm going to hit delete, and it goes to my door again. Simple as that. And you've got the standard control Z, just like you have in Microsoft Word, so you can undo what you've just done. But be careful of that, because it undoes everything. So if you've done something quite major in the last few steps, don't just sit there and go Control Z and keep hitting, because within a few seconds you'll be back to where you started from at the beginning of the class, and you may have done complicated drawings. So be cautious of that function. Okay, I want to join those 2 components together. I want to wire them up. Well, I'm going to bring them a bit closer together because I like my circuit to look nice and neat. And what I'm going to do is I'm going to go to the leg of R1, and you'll notice that instead of having an arrow now, I've got a crosshair, like a gun crosshair. And I'm going to click on there, and look, suddenly I've got a connection hanging off the end of that resistor wire. Now the other thing I'm going to do is bring that down so that it touches on to the end of the other one, and you'll notice it goes slightly red on the end, and then when I click like that, the whole wire goes red. If the whole wire's gone red, it's connected. If it hasn't gone red, it's not connected. And that's one of the commonest faults that you'll come across, is people aren't joining the components together, and it's really difficult to see in a simulation when that connection is broken. Okay, make sure you can do that. Join 2 components together. Doesn't matter which components, join them. You should have a red wire when you finish, indicating that the connection is complete. Yeah? Everyone good to go on that? Absolutely vital skill, that one. Get the components in, get the components connected. You can get a lot bigger than that a lot quicker. So you're okay with that? Remember what you can do now. You can go to the library, you pull in a resistor, you pull in a capacitor, and you can join them together. That's not much of a simulator though, is it? We want to do something a little bit more meaningful than that. So what else do you think we need for a circuit? What is invaluable in an electronic circuit?
Power supply.
A power supply, well done sir. So from over there, you head down there, look. So you need a power supply. Well, what does a power supply look like inside Multisim? Well, let's have a look in here. So let's do place, component, and let's have a look down this list here. So what do you reckon it is, Mike? Do you reckon it's sources, the top one? I reckon it's the top one. So we go into sources, and look what we have there. So listed straight away, we've got all families, okay. We've got power sources, signal voltage sources, controlled voltages, digital sources. I reckon it's a power source myself. Yeah? So I'm going to click on the power source, and what do I see straight away? I see AC power, DC power, ground, etc., etc. I reckon I'm going to use DC power, because DC power is just a battery, right? That's what DC power is. AC is the kind of stuff that you get in the mains, alternating current, waveform. But for a DC power, and you should have all seen the symbol for a battery before, it looks like that. That particular cell, without the dotted lines inside, would ordinarily be 3 volts. But you can change the voltage on here. I'm going to change mine to 10 volts by double clicking on the component. And inside here it says 12, and I'm going to change it to 10. So I've got a 10 volt battery like that. Yeah? Happy? 10 volt battery? Not connected yet, but we've got. So now duplicate the circuit that I have. So you've got a resistor here and a resistor here and a wire joining them, and make sure that you turn the component through 90 degrees so that it's the same as mine. Okay? Can you all keep the cable I've got on the screen? If you can't, stick your hand in it. Okay, give me a couple of minutes to do that. Anybody not there? So on the screens I can see everyone's there, and I can see many people leaping ahead as well, which is good. Okay, so the next thing, well, I like aesthetics, I like things to look nice. So I'm just going to tidy up my circuit a little bit. So I'm going to make it look nice and square and make the components equally spaced. Now the final thing I need to do is make a circuit. Now you'll agree that circuits are closed or closed loops. So what I'm going to do is I'm going to join that wire to there. And this wire along the bottom up to here. Job done, I've got a circuit. That's a real circuit. Current will flow around that circuit. Okay, I see people looking strangely now, which is accusing me that we need a little bit more time. So get that circuit wired up now, and that's what's, well, I am in a second. I am in a second. The two most important bits. But that circuit in its own right is a really, really interesting circuit. It's what's called a potential divider. So we might go to find it here. Okay, you all got that?
0.01 ampere.
Anyone need any help? Not all that. All okay on that? Okay. Whoa, 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 whoa. So that circuit you've got there is what's called a potential divider, and actually I think the vast majority of all those circuits descend down into something that's that simple. You know, what's the magic, what's the miracle of electronics? That is. Okay, well this could be a capacitor here, actually, this could be an inductor, but that's no difference, the maths is the same. That's a potential divider. If I put an input source in here, so that's a 1.5 volt cell, and this is my out here, the amount I get out is proportional to the ratio of those two. That's critical. And I'll show you some wonderful analyses using complex mathematics where you can do that with inductors, capacitors, all the rest. Look right now. So the formula for that, if you don't know it, is V out equals V in R2 plus R2 R1 R2 on R1 plus R2. I can now predict what this will be, given information about this, this, and this. That really is magic. Now the reason I tell you that is because, well, we're going to do some measurements on here, so let's do that. So, Mike, what have I left off the circuit?
The most important bit to make that work is the ground.
Okay, Multisim does not understand circuits which are floating around in free space. And for all intents and purposes, I don't think physics understands things that are floating around in free space. And it's a big problem to do with RF, but we don't need to go there yet. But Multisim must have a ground connection for it to simulate, so we need to place a ground. So we place components. We're in power sources still, and inside power sources we've got a ground. See that symbol? See it on the screen? And what I want to do is I want to say yes. I want to place that ground somewhere near that bottom line and join that onto the main circuit. I've now got a proper circuit. I've I've got a battery, I've got a ground, in this case I've got a potential divider. That circuit will work. We're ready to do some measurements. Right, you want to kill that video and then start again. Okay? A closed circuit, that will work. We can now see